The first webinar of Rhino Grasshopper. This is a webinar that it's been going to be run by me, Aldo Sollazzo, and Efilena Basetta. I am part of the Fab Lab Frosinone, where we are running the program of the Fab Academy, and I'm also the co-founder of the Office Numera. Efilena Basetta is a collaborator of the Office, and is also is part of the Office Numera, and is as well a collaborator of our Fab Lab in Frosinone. This webinar is part of a program that we are running in parallel for the Fab Academy course 2015. The Fab Academy course is a program that is run by Neil Gershenfield, the founder of the Fab Labs from Boston, from the MIT of Boston. And it's basically the official digital fabrication course that involves a lot of Fab Labs around the world. So with our Grasshopper course, what we want to do is to give you the basic knowledge for Rhino and for Grasshopper. We are sorry that we had, we lost basically 5 minutes because we had this little problem with the audio. So let's say that I will leave again now the stage to Efilena. That I'm sorry, she has to repeat what we did, but it's things that happen. But I just want to add a little things. What are we going to do is more or less this. So we're gonna do an exercise in Rhino. Efilena is gonna explain all the interface of Rhino, and basically she will also explain how to modify a NURBS creating this kind of surface. After her introduction, what I will do, I will start to teach you the interface of Grasshopper. So we will see how these commands are subdivided, which is the logic of it, and then we will repeat the same exercise. Okay? Perfect. So hopefully everything is working. I don't know if there is a problem with the audio anymore. If someone in the chat can tell me, is it fine? I hope it is. So if there is any problem, anyways, we will try to fix it live in front. Trying to make you understand, everyone, what we are doing. So enjoy the workshop. Welcome to the webinar, and now welcome to Efilena Basetta.
Hello, I'm Efilena. We're gonna see, first of all, the interface of Rhino. So the main thing that you can see now on your screens, there are 4 views. So it's the perspective view, the top view, the front view, and the right view. So Rhino allows you to design and looking at the same time at the 4 different views and being able to navigate on them. At the top part of your screen, you have a menu with drop-down menus here that you can access most of the commands of Rhino. Another way to access the commands is this main toolbar here, which by clicking to different toolbars, you can have access to all the commands. As you can see, by clicking on different toolbars, this left part of your screen is changing at the same time, and it's known as the side toolbar of the Rhino. So on your right hand, you have some name tabs, the panels, which you can find the properties of the geometries that we design, the layers, the display, that you can change from wireframe to standard to render. And here is the help. The help is going to be very useful for you that you start using Rhino now. So if you make sure that you have activate the auto update box here, and now you are going to see that when we want to create a line, for example, Rhino is giving us some instruction of how to create a line. Every time that we change a command, we see that here the help is changing at the same time. One more important thing is that at the bottom part of your screen, there are the snaps, which is the grid snap that allows you to snap on the grid of the construction plane, as you see here. And there is the ortho, the planar, and very useful is the O-snap, which is the snap on the objects. So if you activate the O-snap, you have some options here, which is the end, near, point, etc., that you can activate with op-snaps you want to have while you design. Okay, let's delete what we have done. And let's talk about Rhino and the logic of Rhino. So Rhino works with NURBS, which are non-uniform rational B-splines, and they are mathematical representations of 3D geometry. This makes Rhino a very accurate design program and flexible at the same time. To explain this a little bit more, I will create a sphere. Okay, which is a NURB polysurface, and I will compare it with a mesh. The same sphere, but with a mesh. So you can see that we have, even if I design the same sphere, we have two different representations. One is with polygons and one is a smooth surface. This will be more clear if I turn these points. So you see that each mesh is defined from points on space that are on the basic geometry, and they are the vertices, while NURBS are represented from these control points that could be outside the surface. And from these points, I can modify my geometry. So from dragging these points up, I can transform this shape. Okay, we're gonna see more detail later on. So the most basic geometry of Rhino are the points. If you hover over this command here, which is the point, you will see two different options. Most of the commands in Rhino, they are different if you right click or left click. So here, if we want to create, for example, multiple points, we have to right click on this icon, and we can draw, for example, 6 points here. If I select one of these points and go to properties and the details, I can see that every point is represented from the three coordinates x, y, z on the 3D space. So having these points here, by double-clicking to the top view, I can only see the top view here now. I will create different curves based on their degrees and control points. So if you left-click on this curve here, command line on the command line is written start of curve, and degree is set to 3. If I press on the degree, I can change it, for example, to 1 and press enter. So now by snapping to these points, make sure that you have your point O-snap activated. I can draw a line with degree 1, which means is a polyline. By right-click on my viewport, the last command that I did is going to be repeated. So I'm going to do one more curve. I'm going to change the degree to 3, for example. And clicking at the same points, I'm going to create a different line. As you see, the two lines, if I move it further down, the two lines are very different. So the degree affects how the line is designed. So by pressing F10 or this little icon here, I can turn on the control points of this curve. So you see that the control points of this curve are exactly the points that I click on. If I want to change this curve, I can start moving these control points. So I select the point, I go to the move icon here, I click, and I can start manipulating this curve. If, for example, I wanted to have a better control on this curve, I could select the curve and rebuild. So I have this pop-up window, and I can select here at the first option how many control points I want to have. Let's say 10 and the degree of the curve. Let's leave it for now 3. We press OK. And now if with F10 I turn on the control points again on, I see that I have now 10 control points. And I can start transforming the curve again. Okay. So in Rhino, the basic geometries that we have seen until now are the points and the curves. The other geometry that we can have are the surfaces and polysurfaces. So we can have a surface, a simple surface, a simple plane, and if our surface is closed, we can have a solid. So in the case of the sphere, it's again a surface, but it's a closed surface, which in Rhino is called like a solid. Okay. Let's create a basic surface, going to here to the surface, plane, corner to corner. So be sure that you check always what is written in the command line. So command line is asking for the first corner of the plane. We can type the coordinates of the point that we want to start. So in this case, it could be 0, 0, 0, and press enter. So we see that the 0, 0 point is locked, and now it asks for other corner or length. Let's do a surface that is 10 by 10 units. So we type 10, enter, and then again 10, enter. So we have our first surface here. Okay. If I turn on the control points using F10, I see 4 points on the 4 corners of my surface. Let's see what is happening. If I select one of these points, I go to the front view and I move these points toward the Z direction. So we see that our surface has been deformed, but still we have 4 control points. We have planar edges, 4 planar edges around our surface, but we just created a double curved surface. As we did before with the curves, let's see what we can do if we want to have a more control to our surface, how we can deform our surface. So if we go back, Control Z, and escape to deactivate the control points, we can select our surface and rebuild it. We have again a similar pop-up window, and we can select how many points we want, control points. So we have here 2 options, U and V, because every surface is defined by 2 directions. So let's say we want to have like 5 control points to U direction, which is this one, and 5 control points to the vertical direction. And press OK. So now again, if I select my surface and turn on my control points, I can see that I have more control points here. One more useful information for you, it is that in Rhino, every surface has a back back side and the front side. Here you can see that in my viewport, I can see that the back side is colored with a different color, and the top side stays gray. To see that, to have this effect on your computers, you can go to Tools, Options, right at the bottom here, View Display Modes, and you can, for example, to your shaded view mode, display mode, you can go to back face settings and set this to a single color and choose the color that you want to have. Okay, press OK, OK. And now make sure that you are in the shaded view, for example, and you can have this effect. This is very useful to know in some cases, and you can, moreover, flip your surface if you want to change the direction. Okay, let's Control Z. And one more command to figure this out is the direction. So if you type dir, it tells you to select the object for direction display, enter, and then you see with the white arrow, it says that the direction of the surface is upwards. Okay, so this is just to analyze and know what your surface is. So now let's go back, select our surface, and turn on our control points and try to transform it. So now it's up to you. You can choose the control points that you want and start moving them to the Z direction, for example, and start creating the form that you like to do. One more tip is that holding the Shift button, you can activate the ortho snap. So yeah, we can play with this a little bit more. Deactivate the points. We see that the surface is keeping the initial information, but a bit distorted. So if we select this, for example, and go to Properties and Details, we see that we have a surface with 3 control points in the U direction and degree 3 and 5 control points to the U and V direction. Okay, that was it. I hope it wasn't very fast or very difficult. And now Aldo is gonna continue with the same exercise in Grasshopper.
Cool. Thank you. So here we are. Let's do something that we have always to do to adjust our screen to the Grasshopper first. We move the properties window a little bit here. It's kind of helpful, so you will see actually both screens. And let's type Grasshopper. Hopefully you all have Grasshopper already downloaded and installed. How to install Grasshopper? You go to Grasshopper forum. Okay, and here there is the section download. Grasshopper is updated very often, so Grasshopper itself will give you an alert when a new release a new version is released. So now you can see, once I type Grasshopper, a new window pop up. What it means? It means that Grasshopper is a plugin. It's not actually working inside Rhino, but needs Rhino to run. So basically, it's kind of we are working on 2 parallel programs that are directly talking with each other. Now I will turn off the Filena div, and I will go to top view in Rhino. So first of all, let's take a look, and let's do this. What is Grasshopper? Grasshopper is programming. So what Grasshopper is, let's say, producing is designing algorithms. Algorithms are a set of operations that solve a problem in a specific number of steps. That's the official Wikipedia explanation that I found for you. So it's programming. Even if we are not looking at a code, actually we are in a code. Even if it's visual, we are doing a program. We are doing, let's say, a programming operation. So how works the interface? You can see we have several tabs here. I have a lot of tabs because I have several plugins, actually not so many, because I just formatted the computer. But you can see we have several tabs where there are a lot of commands. In params, there are all the inputs. Those are called components. So there are all the components that actually import geometries from Rhino to Grasshopper. In maths, there are all the mathematical operations that we can do. Sets, it talks about tree, data structure, and so on. Vectors, it's about, you know, what they say, points, vector directions, and so on. And it's kind of, you know, intuitive to understand. So on curve, we have everything that is regarding curve, surface, meshes, intersection, and then we have, you know, transformations. So you will see that every tab has a sub-menu. So you can click on the black line that is under the icons, and you will see all other icons appear. And you know, that means that all the things that you can do actually don't stop here. You can do basically a lot of more stuff with the Rhino interface. So we said how it works and what are those components. So this is a component. It's a point. And why does it has this color? It's orange because it's empty. And you will receive the information that is empty with a little balloon, a little window that is there. And you know, it's saying floating parameter PT failed to collect data. That means that there is nothing inside this component. So we actually need to put something in it. We have two ways to do it. We can right-click, set one point, and it will go directly to Rhino. We can click again, and the component now it's gray. So there is information. How can I also see that there is actually information going on in this component? I can use something that is called a panel. Panel is in params input panel. Here is it, and as well it's empty. So I can connect with a wire my point to the panel, and now I know that I just insert into this component a point with those coordinates, so x, y, z coordinates. So this panel basically allows me the possibility to read what is actually going on inside the component. Okay, another little information. What happens if, you know, there are a lot of components, basically, we just saw in Grasshopper. Should you remember where each component is? I will say yes, of course, but if you don't remember, you can always double-click on the canvas, and you can always write the name of the component you're searching for, and then press enter. So you don't need to go inside the component. Actually, something also very helpful is that if you open a definition and you don't know where the components are, you can press Control Alt and then left click of the mouse, and those icons will appear. So it will tell you as well where the component is located. So let's go a little bit faster. So I can have the option to create a point. I can also create more points. So I put another component here in my canvas, and I go with set multiple points. Sorry, how I open this window, right click on the component, set multiple points, 1, 2, enter. So if I put a panel now, you will see I have this time 2 points in it. Okay, cool. So what we can do with 2 points? What we can do? Someone wants to say something? Okay, we can create a line. Okay, what is it? This is a polyline component. And where can we find it? In curve, spline, polyline. So I can connect these 2 points to the vector. And here is polyline. Also, we can do this. I have the first point that I created before, and I want to use another component. So create another point. I put it here. No? And I go with this other command, line. So I connect this first point to this other point. Okay? Cool. Now, let me see. Something also important. Now we have, you see, what we have here. We have basically 2 ways of creating a line. What it means? It means that in Grasshopper, there is not always one way to do something. There are several ways. Let's see a 3rd way. I go again in point. Okay, I put 2 components. I copy the 2nd one. How can I copy a component? I left-click with the mouse on the component and then press Alt. And then I can copy components, one next to the other. Okay, this time I'm gonna import a geometry from Rhino. Okay, instead of creating a geometry from Grasshopper to Rhino, I import the geometry from Rhino to Grasshopper. I go to the command multiple points. I put 1 point here and 1 point here. Enter. So, first point is gonna be this one. Second point is gonna be this one. Okay. Again, I want to create a line. So, here is it. Which is the difference? Look, as soon as I modify the position and the coordinates of my point in Rhino, the Grasshopper automatically draw the line between them. So, you know, this is our first algorithm. Amazing, no? Okay, let me erase this information and let me do something that we can do here. I want to divide those curves. So I go, where can I find the command divide? I go to curve, division, divide curve. And what I have here, start to see how a component is based, is structured. Here I have inputs, and on this other side I have outputs. What can I do with this? Here I can insert information, and here are the information are going out processed by the component. So I'm gonna say, here, he's asking for a curve that I want to divide. I want to divide this curve. Then he's asking how many segments you want to generate. By default, I have 10 segments. Okay, I want to change this number. Then let's use a very powerful and probably the most used component in Grasshopper, that is the slider. So I want to use a slider. What is a slider? You know, it's basically a component that works with numbers. And, you know, basically by moving this point along this line, I can have several values. That is, each value, you know, it's divided by a unit of 1 between each other. And the values goes from 0 to 10. How can I modify this? I double click on the slider. And you see, once I double click on a slider, I have several options. The most used options are those. Basically, you can have floating numbers, that means 0.0, okay? And you can decide here how many numbers you want after the comma. Or you can use integers, okay? Also, you can set up here, which is the domain, okay, of the values you have to use. So you can set a minimum value or a maximum value. Let's keep it like this now. It's fine. So I'm gonna now use the slider and connect it here to N. So you can see that as soon as I start to divide and move the slider up, automatically the curve is being divided thanks to the use of this component. Now, again, I'm going to repeat the same operation here. Okay. And here you can see that I have 6 points on a curve and 6 points on the other. You see? But what it happens? You see, actually the points are 7. And if you count, you can see why. Okay? Because it's starting from 0, 1, 2, 3, 4, 5, and 6. What it means? Grasshopper always start, from the number 0. So if you are doing something, always remember that you are also counting the value 0. Okay? So the calculation way from Grasshopper starts always from 0. And that is very important. So you can see I have points on a curve and points on the other curve. Now I want to create lines in between. And let's see, how can I do it? I go with the command line again, and I connect the points of the output of the component divide from my first line with the points from the output with the second line. And here is it. You see? Basically, we are more or less creating kind of a grid structure, let's say. Let's call it like this. And actually, there is a very, very good introductory tutorial of David Rutten exploring and explaining basically what you can do with lines, curves, and so on. And you can find this tutorial on Vimeo. I mean, I will just quickly search for it. David Rutten is the creator of Grasshopper. Let's say it's the genius behind Grasshopper. And you can find his, let's say, Grasshopper introduction in Vimeo. It's very easy to find it. So I don't want to repeat the same. I want to do something a little bit different. But I use this example, just to let you understand more or less how it works and how basically you can start to build your own algorithm and your own design with Grasshopper. Now let's move to the definition that we want to explore. Actually, the one that will lead to this kind of result. Basically, as I told you before, we will repeat what Elena did, but in a parametrical way, let's say in a computational way. So how do we start the operation? We need to start creating our grid of points. So to create a grid of points, we need a grid. So we go to vector, square, grid. Here is it. Okay, what is asking for? Is asking for the base plane for a grid, that is our XY plane. Then is asking for the sides, the dimension of these grids. And the dimension of this grid is 1. And then again is asking how many cells I have in X direction, how many cells I have in Y direction. To repeat what Elena did, I will say we have 10 cells in both directions. Okay? So here you will see, the grid. Now, the grid is done by curves and also by points. Actually, the points are what we want to work with, what we need in this definition. Well, what I see here, I see, two different kind of lines. One line is continuous, and this other line is dot. That means basically that the information are running in two different ways, from this component to the rest of the definition. Here, the information is running in a direct way. Means that basically all the information that is there, is not subdivided in something that is called branches. If not, today we are not going to really into it, but most probably we will have a second webinar where we will see more deeply the concept of data tree. But at least, by looking at the wires, you can see that the difference is really in the structure of the data going from one component to the other. You see how here, using another panel, I have those kind of subdivision. I have, I have, here one unique tree, and here the data is subdivided into, let's say, subsystems, okay, not to be too complex in the explanation. If you want to see it, let's say, graphically, go with this param viewer, use this param viewer that is in param viewer, and you can actually see the structure of the data that is passing from one component to another. By double clicking, you will see that the structure is this in this case. In this case, the structure is this. Okay, we will see again more deeply this information in another webinar that we will do. But at least now you know, at least that, well, I mean, what happened when I have these two kind of different wires. Okay, so good. What I want to do now, I want to generate a surface out of it. How I do it? I go to surface, and you will see in util there is a command that is, sorry, in freeform there is a command that is called surface from points. Okay, so how to generate from points a surface? I have here my points, and that it's easy, and then he's asking in this other input, how many U subdivision do you have? You know, we have here the number 10, but what happens if I connect this value here? Actually, my component is red. Red is an alert signal, an alert message that we have, that we receive. So each time a component is not working, the color becomes red. So basically we have, let's say, three different ways of looking at a component. So it's empty, it's with information working properly, and it's gray, and it has an error, and the color turns to red. Okay, why there is a problem here? Because basically we are saying that the subdivision is 10, but as I told you before, since Grasshopper starts from the number 0, we have to add another number. So we can do this. We can do this. We can type 11, and once you type 11, you already have a slider with the value of 11, and we can input here the value, you know, and it's still, I mean, still creating a problem, but because we have to flatten here the information. Flatten the information again means that basically, look, the data again is going to be structured only in one unique list. But okay, so as I told you, we were here. We had this red component. The problem is that basically we are saying that the U subdivision is 10, but as I told you before, we have to say that it's 11. But you know, this is not very intelligent, because each time I'm going to modify this, you know, I have also to modify this other component. The best way in Grasshopper is more or less to automatize the, let's say, all the process. So let's do this. I have here the first slider, and I want to do a mathematical operation. So I do an addition. I go to math operators. I use the value here, 10, and I say, okay, so the U subdivision is going to always be this number plus 1. Okay? So now I can connect the value of 11 here in the U subdivision. And here is it. Basically, here I have, you know, my surface, the surface that we saw before, that Efilena did with the component of Rhino. Okay, let's see something else. Basically, we generated our surface, but let's go a little bit back again. You see, the components now are shown with this kind of display. I want to see actually the icons. How can I do it? I can here I have the option of drawing the component drawing the icons on the components, or drawing the text. Okay, this is something that depends on you. I mean, I had several arguments with my colleagues. But really depends on you if you prefer to read or just to recognize the components by a simple drawing. Probably for beginners, I still think it's better to use this kind of strategy in order to relate automatically the component with the panels that we have here. So I want now to modify. First of all, let's also do this. I have here a lot of information, and if you see the canvas in Rhino, you can see that actually I see the grid, then I see my points, and then finally I have my surface. Do I need to see each time all this information? No. So what you can do in Grasshopper is also this. You can select the components, and by pressing spacebar, you can see actually you have a lot of information popping up. You see? Basically, you can turn on or turn off the components with these two faces. No? You can also group the components all together. What you can also do, you can turn off the components. No? This is the command able, disable, and enable. And you can also bake the components. What it is a bake? Bake actually is the command, is this egg, this fried egg. Bake is the component that is, let's say, translating the information, basically, let's say, printing, the information from Grasshopper to Rhino. You can see that now, actually, since I baked my points, those points are on my Rhino canvas. That means that those points are baked, okay? Again, I want to turn off the grid. I don't need it. But I want you to keep on looking at the points of the surface. What I want to do now, okay, I want to modify this surface. Okay, in order to do it, I want to, let's say the strategy that I'm going to use is by adding an external element an external element of this surface into the game. Let's see what it happens. I'm going to go on vector, construct point, okay? And here you can see I generated a point that is here, okay? Why it's there? Because automatically the coordinates are set at 0, 0, 0, okay? Perfect. So this is my point. And how can I generate a relationship between those points and these other points? Probably by just doing a little operation that is a distance. So I can calculate the distance from this point to all those other points. So you can see that now actually I have a lot of values, no? Coming out. Fine? Good. So what is happening now that I have this point? I want to use those values, no, to modify the starting point of my surface. I want to move them according to the distance from this other point. I will move all of them up, okay? How can I move something in Grasshopper? With the command move, that is here in transform, Euclidean, move. I'm gonna move my points. So here is asking what you want to move. The geometry I want to move are the points. And which is the value and which is the vector I have to, to use to move those points. The vector is the vector z. You find vector in vector unit z. Okay. Okay, good. And which is now the value that I have to use? Let's use this value and let's see what happens. Okay, wait. What I'm doing now needs, what I need to do in order to see something, I have to move into perspective view. And you will see, because the point is there, I will have this kind of relationship, no? So the movement is slow, is less, is basically is equal to 0, where my starting point is. Okay, nice. More or less we are there, but I still don't like it. Why? First of all, because I don't have so much control on this point. I want to have more control. No, or probably I want to play with it. If I want to play with it, let's add a slider. Okay? And by adding this slider, I can modify the values in X and Y. And you can see that now, the more I move this point, and the more this, let's say, this relationship change. So what we did, again, I have the point on my grid. I'm also, let me use this. What is this? Basically, this is a command that tells me, that gives me the possibility to see only the components that I am selecting. So you can activate it by clicking on it. So what we did in this exercise until now, we had a starting grid of points. We have also this value, this other point that we add. So basically, we have two sets of points. One and all the grid of points. Okay, I generate a relationship, between my single point and all the grid by doing this distance operation. And then what I do is basically according to the value coming out of this distance, I move all my points up. And here is what is happening. Okay, good. Now I want to create, a surface out of it again, to see again my surface, how it has been modified. So I go again with surface from points. So those are my points. And again, my U subdivision is this one. And here is the surface that I'm modifying according to the position of this point that is called attractor point. As you can see, where this point is, the surface has been attracted to this point. But you can see the relation that we have here is kind of brutal. No, we want, a little bit to modify, to smooth these those values. Okay, let's add something more, between here. I want to add a graph mapper. A graph mapper. Okay, cool. Where can I find it? Here, in params input graph mapper. It's kind of an empty window, but if I right-click on it, you can see that I have several graph types: Bezier curve, sine, cosine. Basically, those are let's say curves that allows me more or less to modify the values that I'm inserting according to a specific domain and a mathematical equation between them, between the value. So you also can see that in the graph mapper, I have to set up a domain for the minimum value of z, the maximum value of z, the minimum value of y, the maximum value of y. Okay, in order to have more or less something that we can, it's similar to what we have here, I can see which are the boundaries of the domain I have here. The boundaries mean the minimum value and the maximum value of the values of all the numbers that are here output in distance. So you can see that the minimum value is 0, of course, and the maximum value is 8. So the domain that we are doing, that we have to change here, probably can be kind of similar, or we can decide to do it a little bit smaller. So our graph editor will be set up between 0 and 5 for the x, and 0 and 5 for the y. Good. Now I input here all the value that I have, and I set, and I connect them to the z. What is happening? Something like this. Basically, I start to modify a little bit more. You see, as soon as I play with this curve, I modify more the surface. No? And you can decide, how you want to do it, how you want to modify it. And there are a lot of, also other possibilities that you can use in order to do something like this. But let's say this is very useful and quite easy to understand. So what we have here basically is a surface modified by an attractor point, and we are using a graph mapper to control this this modification of the surface, to design it more. Okay, but always, playing with the values mathematically, without having nothing to do with geometries. So we are modifying numbers, and by the modification of these numbers, this modification is also affecting the final geometry. Okay, in this case, I have one attractor point, that is this one. Okay, what happens if I want to play with two attractor points? Let's see, I copy this component, I move a little bit more the point in here, and what you have here basically is this operation. I have 2 points, and instead of using this that I'm going to erase, I'm going to use the component pull closest point. Okay, good. So let's put those points in one unique component. So I insert this component here and this component here. Let me turn off all these things that we don't need. Good. So I have here the cloud of points to search. And I'm gonna insert here all the values on my grid. Okay? Good. So again, what I have is a list of distances that I'm getting from here. I can use this list here, no? And what you see actually is an error, because what we need to do is exactly to flatten. Those are the mistakes that can happen sometimes. Okay. It's an error because I'm getting a lot of values here. So I have to flatten here the information. Oh, sorry. I have to flatten the information here, and also flatten in here. Oh, 1 second. Let me check that. I did some mistake. Things that always happen. Okay. Okay. New subdivision still fine. Okay, we are having a problem. Those are the mistakes that happen quite often. Let me see. This is okay. Basically, it was my mistake. Basically, I was working. I'm sorry. I was working, you see, with this divided list of values, and I have to work with one unique list of values. Okay, that was the mistake I was having. So what is this? This is a command that you can use actually, to subdivide the information into the separate list or into one unique list. You have several commands: flatten, graft, or simplify. What I did here, basically, I flatten the values. Means that you remember the line from a dotted line, I'm putting all the values in one unique list. So like the continuous line that I have it here. So the result of all this operation, I'm sorry for the problem for the mistakes that I did, but the result is that actually now we have 2 attractor points instead of only 1. So let me turn off the first points. I also don't want to see those other points. This is my starting surface. Okay. This is my final surface, and you can see now that as soon as I move one point or the other, the surface is affected. Okay, so instead of having only one attractor point, I did an operation that connects basically more points as an attractor to my starting grid. Perfect. Okay, and this is already the second step that we did. So now we have 2 attractor points. But what are we looking at? It's a surface. Okay. How can I turn this surface into a mesh? I can, use the command mesh surface. I can type it, or I can go to mesh util mesh surface. I can input here the value of the surface, the output of the surface. So I already have a mesh, but here the subdivision is 5, and here as well it's 5. I want to have the same. Okay, so what I'm doing, I'm following what I already said here. So I'm gonna add this and this. Okay, so now I have the same subdivision of my surface. Why am I doing a mesh? Because what I want to do, I want to color this mesh according to let's say the height of each vertex. So what am I going to do? I'm going to deconstruct my mesh. Exactly. And here you can see that I have several things. I have the vertex and the faces. I'm going to use the vertex in order to color this mesh. So I deconstruct all my vertex. And deconstruct, it's in here. Again, it's in vector point deconstruct. And you can see that from the vertex, I got 3 values. Three outputs. The values of x, y, and z. What I want to do again, I want to color this mesh according to the value of z that I have it here. So to color something, you go to input, gradient. I connect z here. Those are all the values, that I have. And here is also asking, okay, which is the lowest value, like the domain bound that we saw before, which is the lowest value, or which is the highest value of this domain. So I'm gonna use the domain bounds. So I have minimum and maximum again. And then what I'm going to do, I'm going to reconstruct my domain. Good. Reconstructed domain means that I have as an output a starting value, the starting value, and the final value. So we can see that actually I have two outputs. So from, it should be from the lowest to the highest value of my domain. Good. Let me see if everything is fine, or okay, perfect. So the lowest value and the highest value of my domain. So I'm going to connect E here is my maximum value and S to L0. Good. So what is happening? Basically, it's happening that it's taking this component, the gradient component, is taking all the values that I have in Z, and is distributing along this line all this value of Z. How? Knowing that the lowest value is this one and the highest value is this one. Basically, is reordering all those numbers according to, let's say, this gradient of colors. Okay. Now I have just to do one last step, and the last step is to color my mesh. So I go to mesh color. How you find mesh color? You find it here in mesh primitive mesh color. So this is my mesh, fine, and you can see automatically mesh color as this, let's say, gradient pattern. That is kind of weird, and I want to use this other pattern, and here is it. Basically, we are coloring our mesh according to the height of the vertex. You don't like these colors? No problem. You right-click here on the component, and in preset, you have several gradients that you can use. And probably the black and white, it's very easy to read. No, a little bit serious, but kind of helpful. If you want to color and see which is the different of height, or you can see, another gradient can be this one. Okay, so more or less that's it. We saw how to modify a surface in Rhino and how to do the same operation but with a Grasshopper definition. And also, I'm sure that you are starting to understand, which is the added value of using something like this. If I start to modify something here, you see that automatically all the system is modified. So it's a very, very powerful method and can be used as it is in a lot of different fields. So for the webinar, it's everything. This webinar has been recorded on our YouTube channel, and in the Fab Lab Frosinone website you can find all the information of this webinar and future webinar as well. Everything will also be uploaded on the Fab Academy website. That is that you can find at fabacademy.org, and here you can have all the archives of the course of 2015. So I hope that you all like the webinar, and from me and Efilena, that's everything. So Efilena is here next to me, and give a hug to every one of you. So see you soon, and thanks for attending our first online webinar.